So all we're doing is the amplitude modulation. So we have some x of t. And let's say that this is x of s. And so we have some x of t that's related to x of s that we're going to multiply. And what do we multiply it by in double sideband AM modulation?
Delta or something like that.
Two pulses, like a cosine.
Two pulses, which is a cosine, exactly, times cosine of omega naught t. What's the Fourier transform of cosine omega naught t?
S over.
Fourier transform.
Oh.
Somebody said earlier. Two pulses, right? So if this is x of s, and this is just a random, I just picked a triangle, it could be anything. We're going to multiply it by this cosine. Cosine is two delta functions. And where are the delta functions located at? Omega naught and minus omega naught. This is time domain. This is frequency domain. So if I'm doing multiplication in the time domain, what is that in the frequency domain?
Convolution.
Convolution. So if we do the convolution of these two, what do we get? We get two triangles, right? All right, if this one is height 1, what are these guys? We get a 2 pi in here somewhere, don't we? I think we get a 2 pi from the cosine. I'm just doing this off of my head, so I could be wrong. Sampling. 1 over 2 pi? Okay. 1 over 2 pi.
I mean, the magnitude is
Let's see. Yeah. Because I made, okay, this one is pi. Okay, I might have messed up when I did. I think it might be. We'll have to look. Okay, look through this. Actually, do this math out and double check what the amplitude is supposed to be. It's 1/2 or 1 over 2 pi. I can't remember which one. Double check, look it up online. Look it up, it's in the textbook. We can find this in a lot of places. It's actually the easiest place. I should look in the book. Has anybody ever read this book?
The class book?
The class book?
Yep.
All right. You're right, it is just 1/2. All right, so this is just 1/2. Why is this one 1/2 and this one's 1? What equation can we use to show why that is? How about Parseval's conservation of energy type stuff? Okay, but yeah, you're right. On this, it also splits it in half because the cosine is splitting it in 2. Okay, so now we've got two things, and these are both centered at omega naught and negative omega naught. Double sideband, because we have two of them, and we have both the upper part and the lower part of the triangle. So that's why it's called double sideband AM, because we've got two of them, and we've got both of the sidebands. How do we put this back together? We multiply again by the cosine omega naught t. Okay? So to undo this, we take this output, which is y of t, and to make it to where we can demodulate the signal, we're actually going to say, let me get my eraser and go to the next board.
Would it be y of x?
wouldn't it be y of, so this one I'm drawing in the time domain. So I'm just drawing the time domain on this side. So this is y of, oh shoot, this should not be s. This should be j omega. This should be y j omega. I like Laplace transform, so I always try to go there. So now if we want to get to a new equation, so if we say this is equal to y of t, and now we want to make a new equation that we're going to call z of t is going to be equal to y of t times cosine omega naught t. What happens with this one? So this is going to be the convolution of this guy. With what? Two pulses again. The omega naughts are still the same. What's the output of this convolution?
Like the 3 triangles or whatever?
Yeah.
3 triangles. What's the amplitudes of the 3 triangles and where are they located?
One's at the center and it's twice as much as the other two.
Yep, one's here and this is at 1/2. And where are the other ones?
One to the right and one to the left.
One to the right and one to the left. How far out? 2 omega naught minus 2 omega naught. And what's their amplitudes? 1/4. Again, Parseval's theorem. We started off with 1. Now we have 1/2 and 1/2. It adds up to 1. The final solution is 1/2, 1, or 1/4, 1/2, 1/4. Still adds up to 1. Did we create any energy? No. All right. Lost my sheet. There it is. That's it. That's all we've covered this semester. Any questions? Yeah.
Can you release the optional homework answers so that we can like review it before the test?
I will send my grader an email today. He makes the solutions. And I will hope that he has the answers up soon.
Okay.
I haven't worked the homework set yet. So, yes?
So there won't be any Laplace?
No. No Laplace on this test. That'll be the final. Yes?
Do we have a clear sheet for this?
You have there are the 2 handouts that I showed earlier, and then you can have a single-sided, handwritten, 8.5 by 11 sheet of notes.
Are these handouts going to be on T-square?
Say again?
Are the handouts going to be on T-square?
Yes, they are on T-square. I think they're under the resources textbook is where I put them, and I need to rename that folder from textbook.
Is there anything that you would suggest us doing for the third question, that one that like you have to kind of, anything you'd suggest us, I don't know.
Make sure you understand everything. Yeah.
You need to know MATLAB.
I could put something on there where it's like, here's some MATLAB code, fill in the last part of it. I'm leaning away from that.
We don't have a class on MATLAB for that.
You do?
Yeah.
Okay. I won't put any MATLAB on it.
Yay.
MATLAB.
Okay. No, I won't put any MATLAB on it then. So, yes.
Do you have any like practice questions or tests that we could mention together?
There are 3 textbooks in the syllabus. Grab any one of them you want.